You get to see me like waving my hands around.
Yeah, I agree.
Yeah, I never watched it video.
Yeah, you're missing out if you don't get to see me like gesturing.
Just for the fun of it.
All right, so don't even. I'll have to edit that out. Don't read my emails. Don't look at other people's stuff. What's going on? Here we go. So I'm gonna go over one of the harder problems that everybody's been having issues with is the copper problem. Sorting the different coppers out. So what is that? Here we go. Number 7. Hey, y'all need to be quiet and listen. I'm going through stuff now. So I've got the copper problem where you have copper 1, copper 2, and copper 3. The Roman numerals tell you what the charge is on the copper. So this is copper plus 1 charge, copper plus 2 charge, copper plus 3 charge. Now, just as a little hint, because sapping likes to be tricky, look at your packet on that front page that has the charges and tell me what charges copper has in that little box there. Kind of small. Yeah, 2 and 1, right?
Yeah.
So is there going to be anything that goes in copper 3? No, copper 3 doesn't exist. And so that is kind of a little trick. You're going to use all 6 answers, but copper 3 is not going to have any of the answers. Now, let me come over to here to the board, and we're gonna try to figure out a couple of these just to kind of get you started. Because there's 2 that are a little bit harder than the rest. But everybody needs to pay attention to this because these questions, if you haven't noticed, there's 21 questions on here. You're going to do this a lot. And moving into stoichiometry, you're going to do it even more, except that's like this part's just going to be the setup that you have to do before you can even start your stoichiometry problem. And so we're going to start to layer this stuff very quickly, and it's going to get more and more difficult. So let's do, I kind of have it on the board over there, but I want to break it down a little bit and maybe try to give you a system to go by. So let's do this CU3N2, because it has a couple problems that you have to think about to figure out. So my formula is Cu3N2. And I need to know what's the charge of this copper. How many positive charges does it have? First question is, before I can figure this out, because copper could have either 1 or 2, I need to figure out what nitrogen has. Because the positives and the negatives have to even out. I need to have the same amount of positives as I do negatives. So what's the charge for nitrogen? Look on your sheet and tell me where nitrogen's at and what its charge is going to be. It's going to be -3. Is it even on the front page of that packet? No, but it's next to oxygen and it's next to what else? The sulfur there. And those both have a -2. So if the 7th column is a -1 and the 6th column is a -2, then the stuff in the 5th column has to be a -3. They have 5 out of 8 electrons. They're 3 away from the edge. And so when they get those 1, 2, 3 electrons, each electron has a negative charge. It's going to be -3. So my nitrogen is a -3 charge. I'm not going to write this in the formula. They don't write it in the formula, but I need to know it. And if each nitrogen is a -3, and I have 2 of them, how many total negative charges do I have? -6. So -3 times 2 is equal to -6. -6 is what I have here. Now, like I said yesterday, every single problem, you need the same number of positives as you do negatives. You can't have different numbers. That's not how ionic bonding works. You have to have the same number of positives as you do negatives. So on this side, I need 6 pluses. Like I have to have them. Can't be any other way. So if I have 6 negatives, I have to have 6 pluses. But the problem here is I have 3 atoms to split it up in. Like these 3 atoms have to all add up to 6 positives. They can't each be 6, because if they're each 6, now I have 18 positives to my 6 negatives. That's not going to work. So I need to split it up among these 3. So what I'm going to do, instead of multiplying this number by my negative, I don't know my top charge up here. I need to divide. I take my positive and I divide by the number of atoms that I have. So what's 6 divided by 3? It's a +2. So +2 is going to be the charge that I have here. And now when I fill that in, +2, this kind of makes sense. 2 times 3 is 6. -3 times 2 is -6. I have 6 positives, 6 negatives. Everything can be okay. So that is actually my answer. What copper organization is this? Is it copper 1 or is it copper 2? It's going to be copper 2. And you need to do that with every atom. It shouldn't take you that long because some of them you can figure out pretty quickly. Like Cl has what charge to it? -1. Cl is a -1. And if I only have one chlorine, so I only have one negative charge, and I only have one copper, the copper has to be a +1. That's the only other way I can get +1 and -1. So one negative charge, one positive charge, that copper has to be a +1 copper. So go through each of these, and it might take a little bit of time. This is probably going to be one of the harder problems. But you need to go through each of these and look, what is the negative charge on the right side, and what does my copper have to be to get me that positive charge on the left side? That's what column I'm going to put it in. And the good news now is we know it can't be in column 3. It's got to either be copper 1 or copper 2. There is no copper 3. So you can kind of sort them that way. But kind of use this to kind of understand the process, because they're not going to just do this and go away from it. We've done lots of stuff where, you can guess on stuff and then you never see it again, right? That's not, I promise you, it's not going to be the case here. You're going to see this stuff over and over and over again. So if you have questions, let me know. There'll be other problems. I might do another problem on this video. So if the video continues, I did do another problem.